All right, so we are still in 5.5, ready, set, go, and we're going to be doing number 12. Number 12 is a triangle, and then, not number 12, sorry, number 14. Yikes. I saw the 12. That's funny, sorry. It says fill in all of the missing measures in the triangles. Fill in all the missing angles and sides of the triangle. Okay, so anybody notice anything here? Anybody notice? What do you notice here? So geometry is all about noticing. Sometimes noticing the thing that you think is really, really obvious. So anybody notice anything here? The sides are congruent. Good. It is a special right triangle. And someone said, should I be using x square root 2? Kind of. So yeah, which triangle is this? Yeah, this is the 45, 45, 90 triangle. So you actually know this, and you can prove this because there's a theorem that says in a triangle, if two sides are congruent, the sides opposite, the angles opposite those sides are congruent. So if I know that this is congruent to this, right, and this plus this plus this equals 180, and you'd solve that equation, this would be 45. Okay, so this is a 45, 45, 90 triangle. And then the moment that I see this triangle, I want to label it as x, x, x root 2. Now, some of you are like, Ms. Johnson, it already has a 12. So all I'm saying is that x root 2 equals to 12. I should make this a little bit neater. Right? X root 2 equals to 12. Does that make sense? So then I'm just going to solve this equation, and then I'll know what x is, and then I'm done, because all it asked me to do was to find my angles, which I did, and find my sides. So how do you solve this equation for x? What would you do? How would you solve this equation for x? What would you do? So right now you see x root 2 equals 12. How would you get x by itself? Yes, you would get rid of the radical. Let me ask a different question. What's happening between x and root 2? What's happening between x and root 2? Yeah, it's multiplying. So how do you get rid of multiplying? Yes, very good. Divide by what? What am I dividing by? Yeah, root 2. Good job. And how do I know that I need to divide by root 2? Because that's the guy that I'm trying to get rid of, right? So then this side divides into 1. So this is x is equal to 12 divided by root 2. Now, this is where it matters, okay? Because I'm your teacher, if you leave it like this, you are fine. But if you want to take the SATs, most likely this is not going to be one of your choices, right? And they say something like, and make sure that you simplify it, or make sure that you write this so that there's no square roots in the bottom. So one of the things that I need to teach you guys about is, what is it called? Rationalizing the denominator. So when you rationalize a denominator, what you're basically saying is this number down here is irrational. They want you to make it a rational number. So what you do is let me scoot it over here real quick. So what you do is you take your number. Oops, why does it keep doing that? That's weird. Right? You take your number and you're going to multiply it by something. That's the number 1, right? So it doesn't change the value of it. But over here, I have no radicals in my denominator. So let's focus on this. Root 2 times what would get rid of my denominator? Yeah, very good. Root 2. So I'm going to multiply this by root 2. Root 2. Root 2 over root 2 is a fancy version of the number 1. So root 2 times root 2, the reason why that gets rid of it is it's root 4. Root 4 is equal to 2. So my denominator is now 2, which I'm like, yay, because I got rid of the radical in the denominator. On the top, when I multiply 12 times root 2, it is just that, 12 root 2, right? And then you can simplify, because both of these guys are on the outside, you can simplify this to 6 root 2. Okay. So there's my x. So I'm going to write it here and here. Make sense? So if you haven't practiced one for the 45, 45, 90, where they give you the hypotenuse and you have to find your legs, this is a good one to practice. And you'll start noticing patterns if you do enough of them. Okay, this one says, number 15, use an appropriate triangle for problems 9 through 14 to find exact values of the trig ratios. Wait. Yeah. So for your purposes on our homework, 12 root 2 is fine. 12 over root 2 is fine. But if you're going to take the SATs, you're probably going to take, some kind of math in college. Some of your teachers won't accept this as a final answer. They see it as like not simplified, like a fraction that's not simplified, like, 15 over 9. So in reality, there is no problem with it. It's just that before calculators and stuff, when they do long division, you can't divide by a number that goes on forever, right? Because like if you remember decimal division, you'd move over your decimal. Well, you'd have to move this decimal over a lot in order to get the right answer, right? Very good. Okay, so this one says use an appropriate triangle to find the exact values of trig ratios without using calculators. Whenever we say the word exact values, we use this kind of number, not plugged into a calculator. Not plugged into a calculator. So here, they're asking you for a sine, cosine, and tangent of 45 degrees. So of course, I would probably use my generic triangle, my generic 45, 45, 90 triangle that looks like this, where this is 45 degrees, and this is x, x, x root 2. You'll see that a bunch of the x's cancel when we do this. So how do you find the sine of 45 degrees in this triangle, in this example here? How do you find the sine of 45 degrees in this triangle? It's not catching up to me. Hold on a second. What would the sine be in this one? Uh-oh. Do we not remember? What's wrong? Okay, very good. Okay. So you guys got it. It's x over x root 2, which then you can cancel out your x's. So then it's just 1 over root 2, which is a fine answer in my class. But if you get to SATs, they'd want you to simplify. So we'd have to multiply this by root 2 over root 2. So then our answer is root 2 over 2. And some people will want to cancel the root 2 inside with the 2 on the outside. Don't do it, right? Okay. Oh, okay. No worries. No worries. Okay. I can literally copy and paste this for cosine, right? I should be able to copy and paste this exact same thing. So I'm just actually going to write the answer of root 2 over 2. You should know why, right? Because if I'm going to do this, it's x over x root 2. It's the same thing. But what's the tangent of 45 degrees? What's the tangent of 45 degrees? Yes, it's x over x, which is just 1. Right? 1, 1. Perfect. So now you know how to do this. Now you can be able to do the 30 and the 60 as well. Okay. Really good job. Any questions for me? So do you see how I say that if you have this triangle in your head readily available, this becomes easier and this becomes easier because now you're just referencing a triangle that you're known, that is known to you.